Hi guys! This lesson is on equivalent ratios. And before I start this, I want to talk about how we have a new unit that we're doing now. So notice there aren't any shapes or anything like that right now. There will be some later. But for right now, we don't have any shapes. We're just going to be looking at numbers. We're going to be looking at how quantities relate to one another. Ratios and rates and proportions. Those are all ways that we kind of compare numbers with each other and look at them, and it's very useful in real life. I'm working on house plans for us because we're hoping to start building our house next year, and so that's all ratios and proportions, because the drawing of the house is not the size of the house, but it's proportionate. So it wouldn't make sense, like if I were, I'll just show you an example. So like let's say this is supposed to be my living room, and so let's say that this is supposed to be 20 feet and this is supposed to be 15 feet, and when I'm drawing the kitchen next to it, and let's say the kitchen comes off of it and it is, maybe the kitchen is supposed to be, 20, let's say the kitchen is supposed to be 20 feet by 20 feet. Does this make any sense? That's a really big kitchen. I would like to have a kitchen like that. I don't think it will be that big. But just looking at this, do you see how, if I say this is 20 feet and then I say that this is 20 feet, that's very confusing, and it makes it really hard to understand, where things are going to go and how everything's going to fit. I couldn't give a builder something like this. It wouldn't make any sense. So a house plan is drawn in proportion using ratios and rates. So when they draw that, they'll say that, okay, well, from this point to this point, that's going to represent 1 foot, let's say. And so then when you draw something, each of those things would represent a foot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would represent, 10 feet in real life. It's 10 of those little spaces on my piece of paper. So this is one way that they're used. Ratios are also used when we're looking at statistics of things. Or when we're looking at, like right now there's a lot of stuff about the coronavirus where they're giving data compared to each other. So maybe like the number of cases in Oregon next to the number of cases in Washington. And so then those two things side by side, those two numbers side by side, are like a ratio. Okay, because they're comparing two related quantities. People who have the coronavirus, people who are sick, compared to other people who are sick. The thing that's different is that they're just in different states, but they're still the same thing that's being measured, people with the coronavirus. So here we're going to look at some ratios where we're comparing certain types of people to other types of people, but the idea is that they're all people, and so that's what makes it a ratio. So when we do 7th grade math, we will talk about other ways of writing ratios, because ratios can be written in different ways. Ratios can be written, like I can say that something is 5 to 1. I can write it with a colon, or I can write 5 to 1 with the word 2, or I can write it like a fraction. And so we're just going to stick with the fractions because it's easiest. It's something we worked with this year. It makes, especially doing equivalent fractions and proportions, a lot easier. So that's the way we're going to look at it, is just focusing with fractions. So it's not the same as a fraction in what it's telling us, because it's a ratio. So I'll show you how that's a little bit different. So if I take this data from our class, this just gives us small numbers, and the nice thing is that 15, 9, and 6 all have a common factor of 3, and so I'll be able to show you equivalent ratios a lot easier. So if I take this data and I want to write these ratios, so I want to do the ratio of girls in class to boys in the class. So, well, there are 9 girls and there are 6 boys. So that's a ratio of girls to boys. It's not a fraction, because a fraction, we would want that denominator in a fraction really to be like the amount of people in the class, probably. So it's not exactly the same, but you treat it the same. We can put it in lowest terms. And that's how we make an equivalent ratio, is really just like taking a fraction and putting it in lower terms. So 3 goes into 9 and 3 goes into 6. So that means that I can put 3 on top and 2 on bottom. And so I would say that the ratio of girls to boys is 3 to 2. That's how I would say that with my words. The ratio is 3 to 2. But this is a perfectly acceptable answer written as a fraction. Is 3 to 2. Okay. The number of teachers to students. That one's pretty easy. We have 1 teacher to 15 students. So if I said it out loud, I would say the ratio of teachers to students is 1 to 15. Students to boys. Well, there are 15 students total and 6 boys. Now, that I can make an equivalent ratio for by putting it in lower terms. So 3 goes into 15 5 times, and 3 goes into 6 2 times. So the ratio of students in the class to the number of boys in the class is 2. So it's 5 to 2. What that means is that for every 5 students in class, 2 of them are boys. And that means that the other 3 are girls. Okay, which relates to what we did up here. So for every 5 students, there are 2 boys. That's what this ratio tells us. Okay? So then if we're looking at boys to girls, I already did my work on that one. I already have used boys and girls before, and I figured out my equivalent ratio in lowest terms. So boys to girls would be 2 to 3. So that means that for every 2 boys, there are 3 girls. That makes 5 students. Okay? So that's what that means. For every 2 boys, there are 3 girls. For every 15 students, 6 of them are boys. For every teacher, there are 15 students. For every 9 girls, there are 6 boys. Which I can also say is for every 3 girls, there are 2 boys. So if we're looking at equivalent, let's take this one up here. So 3 to 2, I'm going to make a little box here because you have some of your problems have this little chart. This is not drawn very well, but that's okay. Where you are to write equivalent fractions in here, equivalent ratios. So 3 to 2, what if I have a 6 on top? If there were 6 girls, how many of them would be boys? 4. Because look, all I did was multiply those by 2. Okay, for every 9 girls, there are 6 boys. Well, what if I wanted to know for every 18 girls? So let's say there are 18 girls. How many boys would there be? So hopefully you've got 12. 9 times 2 is 18, and 6 times 2 is 12. So all you're doing are writing equivalent fractions. We're just calling them ratios because they mean something, because of the meaning that they have. It means that for every 18 girls, there are 12 boys. Okay, that would be like if we doubled our class with the ratios that we have now. That would be proportionate to the ratios that we have now. Okay? So part of your assignment is filling out some charts like that. So I'll go ahead and, if you look at like here, 7 over 12. If I have 7 on top and 12 on bottom, and you need to write, you're going to be writing in 2 more equivalent ratios. So all you need to do is pick a number to multiply both of these by. Because remember, we're just multiplied by that fancy 1. That's all we're doing, is multiplying by a fancy 1, which means I need the same number on the top as on the bottom. So let's try multiplying by 2. 7 times 2 is 14, and 12 times 2 is 24. And then I could multiply this first one by like 3 or 4 or 5. Or I could multiply this one now by 2. So 14 times 2 is 28, and 24 times 2 is 48. That make sense? 7 times 2 is 14, 4 times 2 is 28, 12 times 2 is 24, 24 times 2 is 48. It doesn't have to be those. I could do other things. Let's see. So I could have 7 and 12, and then this could be 21 over 36. If I do 7 times 3 is 21, and 12 times 3 is 36. I could do 7 times 5 is 35. And 12 times 5 is 60. So those are all equivalent. And all you do is multiply the number on top and the number on the bottom by the same thing. Remember, that fancy 1. So that's how you do that section. This next section, you are determining whether the ratios are equivalent. Are they equivalent? And there's a really easy test to do, and you can use your calculator. Okay? Really easy test to do. So let's take some that I know are equivalent, like 1/2 and 3/6. I know that 1/2 and 3/6 are equivalent. So I can test that by doing what we call cross multiplication. Cross multiplication. If they're equal, when I multiply the top left number by the bottom right number, I get 6. When I multiply the bottom left number by the top right number, I get 6. So yes, they're equal. Okay, now let's take something that I know is not true, like 2/3 and 4/8. 4/8 is a half, and 2/3 is not a half. So when I multiply these two together, 2 times 8 is 16. 3 times 4 is 12. Are those two the same? No, 16 and 12 are not the same. So those are not equal. That's all you do. Multiply the diagonals. Cross multiply. If when you do that you get the same number, then they're equal. And if you do it and they're not the same, then they're not equal. So the first one on your example here, we have 7 is 3/2 and 2/11. Now sometimes you can use those brains of yours, and I can look at this and say 3/2 is more than a whole, and 2/11 is a small amount of a whole. So they're not going to be equal. There's no way. That doesn't make any sense. 3/2 is more than a whole, and 2/2 is a tiny amount. However, you can still use the rule. That's the nice thing, is you can always test it. So I do 3 times 11 is 33, and 2 times 2 is 4. 33 and 4 are not the same, so these are not equal. Okay? So you can use your brain and figure it out that way, like just using your logic skills. But for some of you, that's harder. Some of you fractions just look confusing to you, and so you have to find other ways to figure out those things. So this is one way to do that. Okay? And then this last section, you're supposed to use equivalent ratios to find the unknown value. So for now, I'm going to teach you a better trick later. Okay? But for now, what you'll want to look at is what you multiply to get the numbers that are across from each other. So we're going to do 2 examples here. Let's do 13 is k over 56. equals 5 over 8. I'm going to show you another way to do this later, but for now, this is what we're going to do. So remember that when I do equivalent fractions, I'm just multiplying by a fancy 1. So I want to ask myself, what does get multiplied by 8 to give me 56? That's 7. So that means my fancy 1 is 7 over 7, because 8 times 7 is 56. So that means that K has to be 35, because 5 times 7 is 35. Okay, number 16, this was number 13. Number 16 is 8 over 11 equals 48 over S. Okay, that noise that you're hearing is Hattie's bunny scratching around. He's doing that special for you because he doesn't do that all the time. Okay, so same thing here, but look, this is the bigger number, so I want to look at what gets multiplied by this. What fancy 1 am I multiplying by? Times 8 to get 48. So 8 times what? 8 times 6 is 48. So that means I need to multiply this 11 by 6. Okay, remember you're always multiplying by the same thing on the top and the bottom. Otherwise you change the amount. Because we have to multiply by 1, because multiplying by 1 doesn't change the amount. It just changes the way it looks. So my S is 6 times 11, which is 66. Okay? So you have these little charts to fill out. We already did the first one. Okay? You have these ones to test if they're equivalent. Remember, multiply at diagonals and see if they're the same. 3 times 11 is 66. 3 times 11 is 33. And 2 times 2 is 4. 33 and 4 are not equal. So that doesn't work. And then down here, what do I multiply to get from this smaller one to this larger one? And make sure you're looking at the same, they need to be across from each other. Both in the numerator or both in the denominator. What gets multiplied to get this, and I have to multiply by the same thing on top. All right? So hopefully you can handle that just fine. Let me know if you have any questions. Bye.